Hello everybody. This is ANRF Prime Minister Professor Shankar from Annamalai University, Chidambaram. This may be of interest to scientific and engineering community and general public who may be interested in knowing the state of the art hydrogen technology. This is about ANRF project on hydrogen combustor. And I share with you briefly the first and second quarter research work. In our scope of video, I'll give you some background information, introduction about project activities, research work, and what is the potential end application. Coming to the background information, we are given mandate by Government of India through ANRF, Department of Science and Technology, to initiate research work on hydrogen gas turbine combustor. Host universities Annamalai University. The mechanism of functioning is like this. Annamalai University is 99 years old. They have their practices. ANRF has given us some guidelines. We mingle and do the best of practices for this project. You could see that whole lot of people, right from Registrar Vice Chancellor, supporting this project. Now, brief introduction. Why hydrogen? It's a clean energy source and the gas turbine can operate on demand as well as payload. Challenges are hydrogen generation, storage, and safety. You won't believe if I say in our own country at Neyveli, there's a lot of hydrogen produced and that will be used for this project. Ongoing research and development efforts in the international arena are happening. And why not we do this? That's how we have started this one. Now we have ANRF project approved activities for 5 years, both analytical and experimental. Now, what is the aim and objective? I have been honored to spearhead hydrogen gas turbine research project and take it to technological readiness level 4, taking on board faculty and students. To take host university research to multi-level, engaging in state-of-the-art international research to mentor faculty students. Now, these are the approved activities. What have we done in the last 2 quarters? First, we organized ourselves. To carry out this work, we opened up 4 laboratories: thermofluid laboratory, fuel and control laboratory, surface engineering laboratory, and lab scale testing laboratory. And there's a systems engineering group. Why? Because later on the combustor has to be fitted between compressor and turbine of a proven gas turbine. And one postdoc support in this project. And the first task I did was I delivered a lecture on National Science Day on challenges in gas turbine combustor development for students and faculty, which was widely welcomed. We conduct one-day workshop on March 30, 26 on hydrogen gas turbine, inaugurated by our CEO, Dr. Shankar virtually. And you could see in the dais, he is Dr. Venkataraman from Neyveli Lignite Corporation, Power Director, and Les from Annamalai University. And he was a keynote speaker applauding the ANRF gas turbine project. Here you could see the audience, students and faculty. Then this gentleman is from Quest Global, and he is Sendil Mayahan. He is Dr. Moya, Dr. Ganesh from GTRE, DRDO, and he is Mr. Ramanand Singh, who was earlier with me in GTRO sub GT, or he subsequently in G, and now in Dalmia Bench. And there were participants from DRDO Young Scientist Laboratories and some startups. Now, interestingly, some of the people in the industry would like to do PhD under my guidance. It will be helpful for the project also because of the valuable experience. So, I have applied for guideship approval by Annamalai University Senate. Hopefully, it comes through. I can take a maximum of 8 PhD students. Then 2 semester coursework, PG elective on gas turbine combustion. And why industry-oriented CFD? See, in my earlier experience, I introduced CFD. Because of that, we could reduce the number of costly test rigs. And before material is cut, these days analytical tools are available. We should be confident that 99% of things are going to work before cutting the material. Now, typical combustor configuration, earlier my students worked on it, and there was a ASME poster in the conference, and we did some analysis and showed results also. Similar configuration is start on, but here the injector is a plus atomizer, but it is not going to work in for our project. So I draw from my earlier experience in Liquid Propulsion System Center, Indian Space Research Organization. We did the liquid apogee motor engine, which took us to Moon, which had coaxial injection elements. I plan to use that concept in this project. Then this is the combustor. You can see cut section clearly. Requirement low pressure loss. This is the killing factor. Normally target is 4-5%. With great difficulty we achieve 6%, I tell you. Then temperature compatible turbine. Then multi-fuel compatibility we are talking earlier. It is no longer applicable here because 100% hydrogen is a unique injection characteristic. Research methodology, conceptual design based on experience parameter. Then of course we will present papers in conferences, we will give for review. And what is important, another area is high temperature coating. We use high temperature nickel chromium alloy in these combustors. But by coating this with a ceramic, we get a temperature gradient of 130, which is beneficial to us in thermal management when we experience high temperatures of the order of 3000 in hydrogen combustion. Incidentally, earlier I had experienced FGM, functionally gradient material. ISRO response project I had on INCO superalloy, and we had quite a bit of publications on that. And ISRO also appreciated will be useful for the re-entry vehicle. See, this is the laboratory scale setup I created to evaluate the thermal gradient capability and the thermal shock capability. Now, in this project, it's a hydrogen atmosphere. So, we are to go in for tungsten, zirconium, tantalum coatings. And in the same FGM route, I plan to go. And already we have procurement of lab equipment for this burner rig is in process. We are doing so much of work, effort, energy, so many people. And what is the potential end use? After we bring it to TRL 4 level in 5 years, from TRL 5 to 9 it has to undergo before being retrofitted between compressor and turbine of a proven gas turbine. Our collaborating institutions, Indian Institute of Technology Madras is hub and Annamalai is spoke. We are in the discussion. They plan to do the planar laser induced fluorescence evaluation, optical diagnostic, and National Aerospace Laboratory Bangalore is interested in doing some testing for us. So thank you for your attention.